Now we will understand how this we are using our logic data type in system Verilog. So let us create a module called ex, and I will declare all the input and output ports with logic only. So input logic A and input logic B and output logic C. I will write the code for full adder only, or no, half adder. I will write half adder only. So yeah, so these are the inputs and outputs, and I'm using only logic data type for my inputs and outputs. And I will within a procedural block, I will assign my sum is equal to A XOR with B, and I'm not assigning carry here, and I'm ending this procedural block, and I'm assigning my carry in this continuous block. Assign carry is equal to A and B, and ending this module. So here you can see I have declared all the inputs and outputs as logic. For example, in Verilog, we would have declared inputs as red and output. If we haven't declared, then they would be wire. So wire can be used only with continuous assignment statements, and they cannot be used in procedural assignments. But here what I'm doing, I'm defining all the inputs and outputs as logic type, so that I can use this logic data type anywhere in this module. Like it can be used both in procedural block as well as continuous assignment block. So is this clear for everyone? Is this clear about logic? This example for logic is clear? Yeah. So let us run the simulation and let's see if there is any error. No error. So logic can be implemented anywhere in our module, whether it can be procedural or continuous assignments. Now we will comment this. Let's discuss about some of the data types. Module test. We have discussed about bit type, byte type. So we will code and see how these are used. So I'm declaring one variable as bit A and another variable of bit 7 down to 0 B, and another variable called byte C, and bit byte have int D, and we'll take short int E, long int as F. Yeah, bit byte int, short int, and long int, and within an initial beginning block, I will assign E is equal to 0 and B is equal to 7 and C is equal to -3, sorry, -2, and here I will assign B is equal to -7, and I will assign D is equal to -6, and assign E is equal to 4 and F is equal to 0, and I will display all these values. The value of is percentage B, comma, and B is also percentage. I will display all of them in percentage. I will display all of them in binary except this int type. So I will display them in D. Copy this and paste it over here, and yeah, D, E, and F. Let me change the arguments also. C, D, E, and F. So can anyone tell what is the value of A? What we will get A? Please respond, guys. What is the value of A? We will get obvious. It's obvious that we will get A is equal to 0. Wait a minute. Sorry, there should be a space here. I am getting this many of errors today. Module test and module. Sorry, I missed ending this. Yeah, now I can run this. So let's check our console. So here we can see A is equal to 0. It's obvious. We have declared A as bit, and the value of B is this one. We have declared B as a bit type, but it can store 8 bits. So 7 is converted into bit. We have represented it in decimal. It is converted into binary, and it is stored in binary. So equivalent of wait a minute, let me change it to 3 bit. It will be easy to analyze. Yeah, so the value of A is 0 and the value of B is we are getting 001. I'm storing B is equal to -7, but I am getting B as 001. So can anyone try to find out why we are getting like this? B is equal to 001. The answer should be B is equal to 111, right? Why we are getting 0001? Anyone? So we have already discussed that bit is unsigned. So it cannot store negative values. So if we try to store negative values in this bit type B, so it will convert the negative value into 2's complement and it will store it into the variable. So here if we are trying to store -7 in our bit data type, then -7 will be converted, will then simulator will perform 2's complement on -7 and it will store it in B. So that's why at our output we can see that wait a minute. So the output we can see B is equal to 001. So this is the 2's complement form. So is this clear, right? So we are trying to assign B is equal, we are trying to assign negative number in a bit type. So bit is an unsigned type. As discussed in previous sessions, we have discussed that bit cannot store negative values. So what simulator does is it will convert negative number, it will perform 2's complement on this negative number and it will store it in the bit type. That is our B. So 7, it will perform 2's complement on 7 and it will store it in B. So that's why we are getting 001. Is this clear? So coming to byte is 8 bit. So we are trying to store -2. So what is the output here? We are getting C is equal to all ones 0. So C can store negative values, right? So it is storing the value of C. And coming to int type, we are trying to store, wait a minute, I will try to represent this C in a decimal form so that we can know whether we are getting correct output or not. Yeah, C is equal to -2. So byte can also store negative numbers. So that's why if we are trying to store a negative number in C, we are getting output as -2. And in case of int also, if we are trying to store a negative number, we are able to see here we are getting -6, and the value of short int also we are getting perfectly. So uh, this is how we will get the output when we try to store a negative number in bit and byte and all the data types. So is this clear, right? So now let's see what is the size of every data type. Size of A is percentage %d. So for knowing the size, we will use the operator dollar size. So this is a system task. So using this, we will get the size. And here also we'll see the size. So by using dollar size, we will get the size of that particular variable. And here also I will paste it. Comma dollar size of B. And here also the size of C is percentage %d, comma dollar size of B, sorry, C, and here also. So A is a bit type, so the size of A is 1 bit, and B I have declared 3 bits, so the size of B is 3, and C is a byte type, so I am getting the size of C is 8, and D is int type, so the size of int is 32, and E is short int, so I'm getting 16, the size of E, and F is long int, so the size of F is 64. So is this clear, right? So the size of each data type, is this clear, right? Can we move forward? Are you having
Yes,
any doubt?
yes.
Yeah. So if we want to uh, make a particular data type as unsigned, for example, here D is signed data type by default. That is, it can store negative values. But what if we want to make that D as unsigned? So for making this D as unsigned, the syntax is int unsigned D. So by using this keyword unsigned, we will make that particular data type to unsigned. So bit we will not use unsigned because it is by default unsigned, but int is signed. So to make it unsigned, we will use this keyword unsigned so that it will be of unsigned data type. So let's see the output now, what we are getting if we are trying to store a negative value when we change it that to unsigned. So here we can see the value of D is some value because Here if we are trying to store the value of minus 6 into D, we have changed it to unsigned. So first it will convert 6 into a 32-bit number, and it will perform 2's complement on that number, and it is storing into it, and it is displaying the 32-bit binary number which is in 2's complement form in decimal format. Here we can see we are getting this value. So this is how it will be when we convert the signed to unsigned. So is this clear, right? And if we want to try another, so I'm giving A is equal to unknown and B is equal to high impedance. Now wait a minute. One tick binary unknown, and I will give tick binary high impedance. Yeah. So let's see what happens if we give unknown or high impedance value to a two-state data type. See, if we are trying to give an unknown value to a two-state data type A, we are getting, the simulator is converting it into 0. And for B also, if we are trying to give it a high impedance value, then the simulator is converting it into 0. So is this clear, right? Can we move forward? Yeah, that's what. If we try to give high impedance or unknown value to a two-state data type, then the simulator will convert it into 0 or 1, because two-state data type can have only zeros or ones. It cannot have unknown and high impedance.